Good afternoon. I'm Zhu Qingyu from Nanjing Tech University, China. It's my pleasure to attend this conference. Today, I will give this presentation about effects of the fineness of densified silica film on the hydration of Portland cement. This presentation includes 4 parts: background, text method, text result, and conclusions. As we all know, silica film is a kind of ultrafine powder. It has pozzolanic activity. It can react with calcium hydroxide to produce extra CSH gel. It also can densify the microstructure of hydrate cement paste and improve the mechanical property and durability of cement-based materials. It's also normally used in ultra-high performance concrete. Just as it has small density and small particles, it's difficult to ship and also difficult to storage. So in market, it was normally densified. There are many methods to dispose densified silica film in using process, such as mixing by mixture, ultrasonic treatment by using dispersant. But it's hard to dispose densified silica film to micron-sized particles by using concrete mixture. There are still many large silica film agglomerations in cement-based materials. From these 3 figures, you can see from cement paste, cement mortar, to concrete, even at 1 year of curing, there are still many large silica film particles. So the aim of this study is to discuss the influence of the fineness of densified silica film on the hydration and the properties of cement-based material. We just focus on the size of silica film. The used densified silica film in this study was sealed to 3 series. The dosage is 10%. Water to bond ratio was 0.5. This is the visual morphology of different type of densified silica film. We studied the chemical compositions. You can see the change of the fineness of silica film has no obvious influence on the chemical composition, but it influences the particle size distribution. It's interesting, we also did the BET specific surface area. The change of the fineness of densified silica film has no influence on the BET specific surface area. It's around 30. We also studied the SEM image. You can see the size or the morphology of densified silica film has no obvious change after 1 day of curing. It still exists in the hydrate cement paste with densified particles. We studied the siting time. From the figures, you can see finer silica film requires more water to reach certain workability. The replacement of cement by densified silica film extended the siting time. Finer silica film increases the siting time, but it shortens the time from initial siting to final siting. You can see from 60 minutes to 30 minutes. We also studied the fluidity. More silica film decreases the fluidity of cement paste since it can absorb more water. Finer silica film also decreases the fluidity since it also absorbs more water. The cement paste with 10% densified silica film 1 has a higher fluidity here since it has the Pore effect. We also studied the hydration products of cement paste by using XRD technique. It's interesting to note that at 14 days and 28 days, the peak of monosulfate is clearly found in all cement paste mixed with densified silica film. It's known that the AFM phase is normally poorly crystalline and intimately mixed with CSH. Cause densified silica film is beneficial to the formation of AFM crystalline and is conductive to the transformation of AFT to AFM. The use of finer densified silica film promotes the hydration of halite and increases the CH content at the curing age of 1 day. The occurrence of pozzolanic reaction of silica film definitely consumes calcium hydroxide and decreases the calcium hydroxide content, but the change of fineness has no huge effect on the CH content. We also studied the pore size distribution by using MIP technique. It seems that the change of fineness of densified silica film shows effect only at 1 day. The total porosity or the volume of different pore size has no significant change. This is the compressive strength of cement mortar. The difference of fineness of silica film on compressive strength is not obvious at early age, but we believed, also from the literature review, we believed that dispersed silica film or the silica film treated by ultrasonic can increase the strength of cement mortar. Here is the drying shrinkage of cement paste. We can see after around 14 days, the drying shrinkage turns to stable, but the addition of silica film increases the drying shrinkage. Here we go to the conclusion. Firstly, the change of fineness of densified silica film does not change the chemical compositions and the specific surface area, but the fineness of densified silica film changed the workability of cement paste, such as more silica film decreases the fluidity of cement paste since it can absorb more water. Finer silica film also decreases the fluidity since it also absorbs more water. After mechanical mixing, the screened densified silica film particles remain intact in the cement paste. Because densified silica film is beneficial to the formation of AFM crystalline. At 1 day of curing, the C3A phase is still obviously observed in the samples containing densified silica film, regardless of fineness. But it seems that the addition of densified silica film can slow down the hydration of halite. Finer densified silica film accelerates the hydration of halite, is resulting in the increase of the amount of calcium hydroxide. The addition of silica film increases the drying, the change of fineness, but has no huge influence on the drying shrinkage. Thanks for your attention.